This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on trigonometric equations when we want to list all solutions. So the example we'll look at here is sine of x is the square root of 3 over 2. Earlier we just asked for the solutions between 0 and 2 pi. Now we want to list all of them. So there'll be an infinite number of solutions, and we need a strategy for listing all of those. But we need to know when sine is positive. Now remember, sine represents the y values in the unit circle. So where would the y values be positive? In quadrant 1 and quadrant 2. So we know we're going to have a quadrant 1 and a quadrant 2 solution. But we also need to ask ourselves what the reference angle would be. And in quadrant 1, the reference angle is pi over 3. The sine of pi over 3 is root 3 over 2. In quadrant 2, we go to pi and then back it up pi over 3. So in quadrant 2, our angle of interest will be pi minus pi over 3, pi over 1 minus pi over 3. Remember our strategy? Pi times 3 minus 1 times pi. Pi times 3, 3 pi minus 1 times pi, pi over 1 times 3. So we get 2 pi over 3. So my first revolution answers are pi over 3 and 2 pi over 3. But I need all of them. So pi over 3, but I could also add another 2 pi. It could be pi over 3 plus 2 pi. Or pi over 3 plus another 2 pi. So pi over 3 plus 2 times 2 pi. I could also go backwards 2 pi. I could go pi over 3 minus 2 pi. So basically, each one of these has an infinite number of coterminal angles, but they all differ by 2 pi. So for the case of pi over 3, I'm going to add 2 pi times some integer. For the case of 2 pi over 3, I'm going to add 2 pi plus times some integer. So plus 2 pi k plus 2 pi k. That will be our strategy. Now recognize the period of the sine function is 2 pi. That helps. But the unit circle's period is 2 pi. That's a bigger issue. So the way we're going to write our final solution is pi over 3 plus 2 pi k, comma 2 pi over 3 plus 2 pi k, where k is any integer, either positive or negative. Remember, integers 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, or 0. And all that's going to do is move you around that unit circle k number of times. So the sign will be the same for any of those values. Okay, let's look at another question. What if I have tangent of x equals 1? What are we going to ask ourselves here? Well, where's tangent positive? Now remember, tangent is sine over cosine. And we know that tangent is positive in the first quadrant and the third quadrant. It's positive in the first quadrant because sine and cosine are both positive. Sine divided by cosine is positive. It's positive in the third quadrant because sine and cosine are both negative. So sine divided by cosine would be positive. So we're looking at quadrant 1 and quadrant 3. But I still need to figure out my reference angle. So when is tangent 1? When does tangent equal 1? Tangent equals 1 if we are at 45 degrees or pi over 4. So the reference angle is pi over 4. So in quadrant 1 it's pi over 4. We need to think about what it would be in quadrant 3. Well, in quadrant 3 it is pi plus pi over 4. You'll notice pi over 1 plus pi over 4. 4 times pi is 4 pi. 1 times pi is 1 pi. 4 pi plus 1 pi, 5 pi over 4. Well, when do I get back to this pi over 4? It could be pi over 4 plus 2 pi, or pi over 4 plus 2 pi twice, or pi over 4 plus 2 pi 3 times. So again, you could see pi over 4 plus 2 pi times k. Similarly, with 5 pi over 4 down here, add 2 pi, add another 2 pi, or subtract 2 pi. So we can add 2 pi k to both of these. However, I want you to notice something. 5 pi over 4 is 1 pi away from pi over 4. So in reality, if I listed out all these values, it would be enough to say pi over 4 plus pi times k. And what you'll notice about that is the period of the tangent function is pi. So indeed, all of these, since 5 pi over 4 is pi away from pi over 4, just adding 1 pi gets me there. Adding 2 pi gets me to pi over 4 plus 2 pi times 1, etc. So this is a simpler way for us to write that, although that first technique isn't incorrect. It's just unnecessarily complicated. And let's take a look at one more question in this lesson. This time we're going to say cos of 2x is negative 1/2. Now my goal here is going to be to solve for 2x. I'm going to do it just like the first two problems, solving for 2x. And then at the end I'll divide by 2. So we still have to ask our standard questions. Where is cosine negative? Remember, cosine represented the x values. So where would the x values be negative? In quadrant 2 and quadrant 3. So the angle that we want to start with has got to be in quadrant 2 and quadrant 3. But we also need to know a reference angle. So what would the reference angle be? Cosine of what is 1/2? Cosine of pi over 3 is 1/2. So I need to find a representative of pi over 3 in quadrant 2 and in quadrant 3. So we're going to go to pi and then back it up pi over 3 in one case. In the other case, we're going to go to pi and extend pi over 3. Those will give me my quadrant 2 and quadrant 3 angles. So pi minus pi over 3, 3 times pi minus 1 times pi over 1 times 3, 2 pi over 3. My quadrant 3 angle, pi plus pi over 3, 3 times pi plus 1 times pi, 4 pi over 3. So those are possible values for 2x. 2x could equal 2 pi over 3. 2x could equal 4 pi over 3. That is just in my first revolution. But the fact of the matter is there are an infinite number of coterminal angles. I could add 2 pi k to this for any k integer. I could add 2 pi k to this for any k integer. So what I can argue is 2x, what I'm starting with, could be 2 pi over 3 plus 2 pi k, where k is any integer. Or 2x could be 4 pi over 3 plus 2 pi k, where k is any integer. Except I don't want to solve for 2x, I want to solve for x. So all I've got to do is divide both sides by 2. If I divide the first side by 2, I get x. Divide this guy by 2, I get pi over 3. Divide this by 2, I get pi k. Similarly, dividing this by 2, I get x. Dividing 4 pi over 3 by 2, I get 2 pi over 3. Dividing 2 pi k by 2, I just get pi k. And I want you to notice something. The period of cos 2x, is pi. It constructs 2 cycles in 2 pi, so 1 cycle in pi. So we shouldn't be too surprised that the cycle that we're seeing here is pi, that it's repeating every pi. And I want to finish this by writing it in set notation using curly braces, and I will do that as follows. Pi over 3 plus pi k, comma, 2 pi over 3 plus pi k, where k is an integer. And that will conclude this lesson.